So I taught the lesson last time, and Oliver's gonna do it this time. So what Oliver's gonna teach us today is about genetic drift, and then also how either a species will go extinct or an emergence of a new species will happen because of the response to an environmental disturbance. So for that, it's going to learn about genetic drift and two new concepts. So as soon as Oliver's done licking his leg for some reason, we're going to get started. So let's wait.
People, let me tell you about my best friend. He's a warm-hearted person who loved me till the end. People, let me tell you about my best friend. He's a one-boy cuddly toy, my up, my down, my pride and joy. People, let me tell you about him. He's so much fun. Whether we're talking man to man or whether we're talking son to son, 'cause he's my best friend. Yeah, he's my best friend.
So let's recap on what makes a species a species. Basically, it's the potential to interbreed and produce a viable and fertile offspring. So that means that they got to make babies, and then the baby's got to live, and the baby also has to be able to produce a baby of its own. So it can't be sterile like the mule, which is a donkey and horse hybrid. So these are usually the things that that separate species. So this is like what makes a species a species. These are like the typical ones. It's going to be habitat, like if they live in different locations, which I add in the bottom, but if they live in different locations, like our eastern and western lowland gorillas, they're all gorillas, but just because they live in a different habitat or location, they're considered a different species just because of the area they live in. Temporal, that's another fancy one for when their mating season happens. They mate at certain times, which makes them different species because they're not able to reproduce with each other. Behavior, it goes along with like mating rituals, like peacocks love to show off their big feathers, or some birds also like a certain song or a dance to be done in order to mate. So if one species does it, another one doesn't do it, then they can't interbreed with each other. Another one is, of course, mechanical. That's like how I said, the pieces don't fit. So if you're a giraffe and a horse trying to get it on, not going to work out the height difference, or if there's like your genitalia is faced the other way. And then, of course, last but not least, chromosomes. So you don't have the same amount of chromosomes. Even if you do somehow try to reproduce, nothing's going to happen because you're not going to get a living offspring. So that's what we make. That's what makes a species, is basically making babies and having their babies make babies. Then also these are the common like separations of what separates a species. It's the location, habitat, the mating season, how it prefers to find a mate for its behavior, mechanical, and then chromosomes. So now to continue on the lesson with Oliver. Alright, so now that we are done, or well, he's done licking himself, Oliver's going to teach us about genetic drift. So what genetic drift is essentially all when alleles or traits become more frequent in a population due to changes in the environment. So when we say that, we mean like the alleles. The traits are going to increase the fitness depending on how the environment's going to change. Oliver says that there's two main examples of genetic drift that we're going to talk about in class. The first one is the bottleneck effect. So it's where you take your bottle and you grab it by the neck and you just shake it. Oh, he didn't like that. Sorry, Oliver, I'm abusing you in front of the kids. Anyways. Alright, so grabbing a bottle by the neck and shaking it isn't the bottleneck effect, right, Oliver? So what it really is basically when a population is reduced drastically in numbers, only leaving a small portion alive. So this could happen because of the environment. It could either, most commonly in nature, it's like due to natural events or weather. What am I trying to think of? Yeah, sure. Like tornadoes, floods, forest fires. So when you have a huge, big population, like we see with this Cholula bottle, we have the big population, and you're squeezing it down to only a small percentage in that bottleneck right there. So you're going from a large amount to a tiny amount, and those genes and alleles are going from a big diversity down to a small singular portion because of changes in the environment. And here's a really good example of one. And you guys know me, so I like chickens, so let's talk about the Great Prairie Chicken. Before we do, you should get acquainted with the Great Prairie Chicken. So enjoy this little video of the Great Prairie Chicken.
Early March. A dry wind has erased the snow from the blue hills of Kansas. Last summer's grass is now a dead sea of straw. One animal is impatient for spring to arrive. These prairie chickens are strutting their stuff, hoping to catch the eye of the gals. Fancy footwork and a bit of clucking. But the ladies have seen it all before. They like their chicken tough. The gents have got to puff themselves up and duke it out. Defeat and victory. This lady's picked her man. But the other suitors can't bear it. Jealousy and outrage reignite.
You know a little better about the Great Prairie Chicken and also what it looks like and where it lived, which is Illinois, where we all live, I think. Pretty sure we all live here. Right now you see an image of the Great Prairie Chicken's range in 1820, and then we're compared to now in 1993. So we could see it went from a lot to a little, and that is an actual bottleneck effect too. It had a large original population, then an event happened. Basically, we took over and all the land, and its surviving population is now very small and only 2 populations. So this bottleneck effect is affecting its allele frequencies, or the traits that are frequent in the population, as you see in the image right here. So now that we know that a bottleneck effect, which affects the traits or alleles, will also result in a new potentially, not always, but potentially result into speciation, or how an event like this will change the population's traits, their allele frequencies, and then also create a new species along the way. Another circumstance that could explain or shows genetic drift is going to be the founder effect. So basically we have, right now in this illustration, we just got a group of flowers. This is just one species, but they have 2 variations of color, blue and red. They're on the mainland. Then we have a new island, but on this new island we get a big hurricane comes by, and it's going to blow some of the pollen and seeds from the mainland to the from the mainland to the island now. And since nothing was there before, they're able to establish complete dominance. So it's nothing but red flowers right there. So after a while, when these flowers on the new island, they start to breed, and over generations and generations, there'll be solely and purely only red flowers compared to the variation of red and blue. So this the change in their frequencies of alleles or their traits, that they're always going to be red, that's actually enough to make them a new species of new solely red flowers instead of the 2 flower color variations on the mainland. So the founder effect is where there's a new land or there's new available space anywhere and somewhere, and then a small sample of already existing species comes by and establishes dominance, or just establishes themselves there, and then through generation they just get like a pure solid form of whatever they want to be. So it could either be colors, it could be height, it could be whatever. So that's the founder effect, when they are the first new species, or they're just the first living things or organisms on that new chunk of land. It could be an island, or it could be a field, it could be grassland, it could be anything, as long as they are the founding species there, and then they're just going to establish dominance, and then they're going to keep on going through evolution, or generations upon generations of reproducing to get a new pure strain, because this is a smaller population compared to the bigger one, and it's just a small portion. So because they're going to be purely red and not red and blue, this is enough to make a species, a new species. So just to recap, species diversity will change in response to the environment because of genetic drift. And we have 2 circumstances of genetic drift, which, remember what genetic drift is. It's when the allele or trait frequencies change due to environmental effects. And that could be anywhere from like a forest fire, a flood, tornado, whatever. Whatever the environment may throw at you, even us humans, we do affect the environment. So even our actions that change the environment that animals have to adapt for, that will make a new species. And we have our 2 circumstances: the founder effect, where a new piece of area is ready to live in, and whatever species is there first gets there, and then through generations it just becomes its own species that's recognized in that central area. And also a bottleneck effect, where we have a large population but then it's shrunk down to a smaller population, and whatever that small population has for those frequencies are a percentage of that larger population. So we have bottleneck and the founder effect, which basically is genetic drift, how traits or allele frequencies change due to the response to an environment, and that's how we get new species. So that's that. Please look at your notes if you're a little lost and confused. If you have any questions, feel free to email me. Then also do the easy assignment. It's not too bad. Have fun. Good night.